Welcome to lesson 2 of our CCNA Practical Labs course. In this course, we are going to explore the following CLI commands. Before we start execution of those commands, we are going to set the DHCP server on router 3. We are going to assign IP address on the Ethernet interface of 0/3 on the router. And we are going to assign it to the subnet of 192.168.100.0/24. You can see the topology which we are going to use. We are going to have one router, one switch, and 3 Windows 11 PCs. In order to add this kind of topology, you need to right-click, say Node, say IOL, and choose for the switch we are going to use x86-64 CRB Linux L2 Advanced Enterprise K9 MS. And for the router we are going to use this image. Both of these images you can download from the sites which were mentioned on the EVNG course. I have already downloaded and installed it. Let's see the specs which I set for the router. So the name is R3. The amount of RAM is 1024 megabytes. So they are all default. I just changed the name. If we look into the switch has also default configuration, just the icon I changed to layer 2 switch. Originally it was a layer 3 switch icon or a router icon. Then I add 3 Windows 11 PCs. Let's see their configuration. The standard configuration contains 4 GB of RAM and 1 Ethernet port and 1 CPU core. In this configuration, I just increased the number of the CPU to 4 and the Ethernet ports to 2 on the first PC, and on the rest PCs I left the quantity of the Ethernet ports to 1. Then, as you can see in the design, I have connected Ethernet 0.0 to the internet or my home network, which is 192.168.13.0/24. Now we are going to add this network on the interface of router Ethernet 0/3, and we are going to assign a switch VLAN 1 the IP address of 192.168.100.10/24. And as you can see here, we have 3 PCs attached to Ethernet ports of E/1, E/2, and E/3. We are not using any VLANs here. They are both located on the default VLAN 1. So let's start from the configuring the router, but in order for you to be sure that the configuration is blank and nothing is there, I just right click and say wipe. Then I say yes. Then I also right click on the switch and say wipe. Then I say yes. What we just did, we have just removed all kind of configuration if they were previously set by me on this lab. Then for the startup configurations, as you can see, I have set both switches to off. It means while the router 3 and switch 3 booting, they will not get any configuration from the EVNG and will use the default configuration which comes with the iOS image. Let's start the router and let's start the switch. As you can see, they are starting now. And let's start the Windows 11. Start. All 3 PCs are starting. Let's log into the router. As you can see, the router is being booted. Let's say enable. Let's say show run to see the running configuration. As you can see, we are having a blank router configuration. It doesn't have any config other than the DHCP client on the Ethernet 0/0 and nothing else. Also in the VTY line 0 to 4, it has a transport input set to SSH only, which we are going to modify in upcoming minutes. Let me show you one more thing, show version, where you can see that I'm using the latest IIL operating system, which is from 2023. And the same situation is applicable for the layer 3 switch, which I will show you later on. And the version of the iOS is 17.12.1. What does it mean? It means that we have all the latest XC image features and capabilities in our hands. So first of all, let's switch to the configuration mode. And change the host name to R3. Next, let's set the DHCP server in R3 for the network of 192.168.100.0/24. And let's exclude the IP addresses from 1 to 99, so the DHCP server will not distribute them to the clients upon request. For this, we say IP DHCP pool, and we call the pool as, let's say, DHCP pool, let's say 100. Then we say network. It means which network we are going to use inside this DHCP pool. It is 192.168.100.0, and the subnet mask is 255.255.255.0. By the way, setting the DHCP server on a router is a CCNP topic, but to see the big picture, we have to set it here also. And let's set the DNS server IP address, which this DHCP server is going to distribute. Let's say DNS server, and let's put a Google DNS here, which is 8.8.8.8. Okay, and now we have to add the exclusion part. IP DHCP. Let's exit from the DHCP configuration mode. IP DHCP. Excluded address 192.168.100.1 to 192.168.100.99. So within this range, upon the request of any client to this DHCP service on our router, the IP addresses starting from 1 to 99 will not be distributed. It means that we can use them statically somewhere else in the same network. Okay, now let's set the IP address for the Ethernet 0/3 interface, which is this one. We say interface Ethernet 0/3. Now we are in the configuration mode of this interface, and we say IP address 192.168.100, let's say 10. And the subnet mask is 255.255.255.0. And let's enable this port. We say no shutdown. And the interface should move to the up state now. Okay, now let's configure the network address translation configuration. Network address translation configuration is necessary for the computers which are here to access the internet, or let's say for the switch which is here to be able to access the internet. For the network address translation configuration, we have to execute the following commands in the global configuration mode. We should say IP NAT inside source list 100. 100 is the access list, which we haven't defined it yet, but we will define it now. Interface Ethernet 0/0 and the command overload. What does this command do? It says you should NAT everything from inside, which is mentioned in the access list 100, which is going outside of the interface of Ethernet 0/0. In our case, it is one port of our router. And then the command comes overload, which means that we have to do PAT, port address translation. Now let's specify the access list. We say IP access list. We need extended access list, and let's give it number of 100. So the NAT rule will use this 100 access list, and now let's define what is inside this access list, what kind of rules. We put a remark, let's say remark. Remark is like a note. Let's say this is the ACL for source NAT. Let's say enter, and now let's the rule itself. We say permit IP 192.168.100.0, and then the subnet mask of 255.255.255.0. But when we are doing ACL, we should use wildcard mask, which is quite the opposite of the subnet mask, which is 0.0.0.255. And the destination any. What does it mean? It means that if somebody is coming to you with the subnet mask of 192.168.100.0 with the destination address of anything, you just allow it. And then the IP NAT here can see that if the packet is coming to me and destined to the default gateway, I should allow it. And I should overload it, means I should do port address translation. Okay. Now we exit from the configuration mode. The ACL is ready. The network address translation is ready. The DHCP server is ready, and let's check if our computers are able to receive the IP addresses. We click on one of the computers. We say trust. The default username is test123. While it is loading, let's open other PCs. Open. Trust. Test123. While this is loading, let's open the last PC. foxes. Test 1, 2, 3. Okay, let's see if the first one has been loaded. Let's click on the command prompt and see the IP address configuration. IP config. And as you can see, the device has received the IP address of 100.102. Do not pay attention to the IP addresses that I planned for these PCs initially here. It was just from the planning point of view, it's not mandatory that they have to match. So let's ping, let's say yahoo.com. Looks like the system didn't receive the default gateway. Looks like we didn't specify the default router configuration. Let's go and check our DHCP server configuration. Yes, you see, we have specified the network, we have specified the DNS, but we didn't specify the default gateway. Let's fix that mistake. Okay, let's say IP DHCP pool. And pool is DHCP pool 100. And let's say default router is 192.168.100.1. Let's save the configuration by saying do right. And let's check it. Do show run. We can see here we have IP DHCP excluded range. IP pool of 100 is this network with this DNS server IP and with this default router IP address. We already have a DHCP client on Ethernet interface 0/0, which is this one. We have an IP address set on Ethernet interface 0/3. We have an ACL rule here, extended access list of 100 with this rule. And let's try again. Now let's say again IP config /renew. Let's see what is going on with our virtual PC. Looks like it is having problem to renew its IP address. Let's reboot it. Restart. The operation of the graphical user interfaces in EVE-NG like Windows 11 Pro is a little bit laggy, so you shouldn't rely on it completely. While the Windows is booting, we will go back to our CLI on router 3 and let's run one of the command IP. Exit again and say show IP DHCP binding. As you can see here, we have a list of IP addresses already assigned by this DHCP service to the client computers. IP address 100, 101, and 102 to the following MAC addresses. It says that the lead's expiration time, when it's going to be expired, the state is active, and the interface on which the request was done. In our case, it's Ethernet 0/3. Let's try to log into our first PC again. Test 1, 2, 3. Let's go back to the CLI and say ipconfig. And as you can see, we have a DHCP router now, also set. Let's do the ping to yahoo.com. Let's see if we are able to ping from the router. Ping yahoo.com. We can. It means that we have internet. Let's see if we can ping the router. Ping 192.168.100.1. Looks like we still cannot reach the internet, and the primary reason for this is that we haven't defined in the router which interface is inside and which interface is outside. So let's do it. Because the router itself has internet, but it still cannot do properly port address translation. Let's say configure terminal. Let's say interface Ethernet 0/3 IP network address translation inside. Enter. And interface Ethernet 0/0 IP network address translation outside. And let's save the configuration. Check again. Show IP interface brief. Oh, I think we did one small mistake. We have assigned Ethernet 0/3 to the router while we were planning to assign this IP address to the switch. So let's fix it. Configure terminal. Interface Ethernet 0/3 IP address 192.168.100.1 255.255.255.0. Let's save it. And now let's try again. Ping. Now we can ping the interface of the router. Let's check if we can ping the Yahoo. And we can also ping the Yahoo. As you can see, our computer has access to the internet. Okay, next in the list, we are going to enable password on our router. For this, we go to the router. Why we need to enable password? The primary reason that because we are going to connect to the VTY lines via Telnet and SSH, in order to log into the router should have an enable password set or enable secret set. Otherwise, the system doesn't allow you to shift to the enable mode. So in the configuration mode, we say enable password 111. For the switch, we will set the enable secret of 111. So the password of the 111 inside switch will be encrypted. Let's also add two users to the router by saying username, let's say Bob, and the password is 222, which is not encrypted. And let's add one more user, Mary, with the password of 333, which is also stored not encrypted in the router. Next, we will set the VTY lines. We will say line VTY from 0 to 4. We totally have 5 lines. What does it mean? It means that maximum we can connect at the same time with 5 different sessions. I will show you that this limitation works in upcoming sections of this lesson. Then we say transport input, and the options are all, SSH, Telnet. We just want to be able to log in with two protocols. One of them is SSH and the other one is Telnet. So we say Telnet, then put a space and say SSH. Then we should say login local. Login local means that we are saying to the system that you should now use these locally created credentials like Bob and Mary with their username and passwords in order to connect to the VTY lines like Telnet and SSH. Okay, I think the router configuration is complete now. Let's check if we are able to connect to the router. Actually, it is not complete. One more additional configuration that we need to do on the router is to set the crypto key generate RSA. What's this command for? This command is creating a public and private key pair for the SSH client. So normally now we will be able to log in via Telnet, but we will not be able to log in via SSH because SSH needs a public and private key pair to be created first. And before this public and private key pair will be created, we need to specify the IP domain name. What's that for? The public and private key creation procedures requires that you have some kind of domain. In our lab, it can be any domain like example.com, example.org, whatever. But for the simplicity, we will name our domain name, and our domain name is Business Network Academy. So we say bna.com. So we say exit. Then we say crypto, or not crypto. Let's start from the domain name creation. We say IP, domain, name, Business Network Academy.com. Then we say crypto, key, generate, RSA. Then we say modulus. And we have a key size from 2048 to 4096. In this latest version of the iOS image, the minimum key size allowed is 2048. Let's use it, 2048. As you can see, the system has generated the key. Let's check if this is the reality. Let's say show run. Do show run. We can see the configurations which we already done. We can see our enable password. We can see two usernames created with the non-encrypted passwords. We can see the IP address on the Ethernet 0/3. We can see our Ethernet and NAT configurations. We can see our login local and transport input telnet configurations. And we don't see any public private key. Let's read why. The system says that crypto-key generate RSA model 2048 is hidden command. Use this command is not recommended, supported, and will be removed in future. Crypto Engine 5 Key Edition, a key named R3BNA Business Network Academy.com has been generated or imported by Crypto Engine. SSH 5 enabled, SSH 2.0 has been enabled. So by default, the latest operating system of the iOS uses SSH 2.0. It doesn't support the old ones. Crypto Engine 5 Key Edition, a key named R3BNA.com server has been generated or imported by Script Engine. So the key was generated, but it's not visible. It is stored in the iOS file system. Now let's say do write to save all this from the running config to the startup config. And let's go to our Windows 1 and check if we are able to log in via telnet to the router. We are going to use a putty client, which comes by default with this Windows 11 installation from the EVNG. The IP address that we are going to query is this interface of the router, which is 192.168.100.1. Let's save it with the name of R3. Let's say save. And let's say other and telnet from here. And let's say open. As you can see, we are telnetting to R3. It is asking us the username. Let's use the Bob's username and the password of 222. As you can see, we are in the exec mode of the R3. Let's say enable. And the exec password was 111. And as you can see, we are on R3. Let's say show run. And as you can see, we are able to reach the R3 CLI via telnet from our Windows 11 computer. Let's exit from it and try to log in with SSH now. Let's load the same configuration. Load SSH port 22. It is default because we didn't change anything, and let's say open. As you can see, we are faced with the warning that the server host key is not cached in the registry, that we don't know about it. You have no guarantee that the server is the computer you think it is, blah, blah, blah. Actually, we know that we are connecting to our router, that there is nothing else in our topology. Then we can say accept or connect once. Let's say accept so that it doesn't ask again. The key warnings. Login as, let's say, Bob. And the password is 222. And as you can see, we are back to the R3 console. Let's say enable. Enable password is 111. And let's say show run. And as you can see, the host name is R3 and we are in our router. And we can do whatever we want remotely. In our case, remotely from this Windows 11 PC. Let's configure our switch tree. Let's console to switch tree. Let's say enable. First, the thing that we can do is change the switch tree name. Say configure terminal. Host name SW3. Let's also check that we don't have any other configuration inside our switch. Let's say do show run. As you can see, it's blank with default configuration. No any settings. The VTY line has only transport input for the SSH and only command of login, which we are going to change in upcoming minutes. So let's assign the IP address of 192.168.100.10 to the VLAN 1 interface of the switch, so that we will be able to manage this switch remotely from a PC or from another router or another switch. Let's say interface VLAN 1. VLAN 1 is the default VLAN where all the ports are assigned to. Let's check it. Do show VLAN brief. You can see that VLAN 1 is active on Ethernet 0, 1, 2, and 3. Because of this, we are assigning to the layer 3 VLAN interface an IP address so that it will be able to manage this switch via this Ethernet ports. We say IP address of 192.168.100.10 with 24-bit mask, and we say no shutdown. Let's check. Do show IP interface brief. We can see that the VLAN interface has this IP address and it's up. The VLAN interface is up. Now we have an IP address, we have a mask, but we need a default gateway in case we want to, let's say, ping the internet or do something outside of this local network of 100.0. We need a default gateway. In layer 3 switches, or in the modern layer 3 switches, the default gateway command is not working, so that we have to use IP route. And we can say IP route of 0.0.0.0 with subnet mask of 0.0.0.0 is available via 192.168.100.1. Enter. Now let's enable secret on the switch. We say enable. Instead of password, we say secret so that it will be encrypted, but the value is same. It is 111. Okay. Now let's create the public and private key pair. But before that, we will set the DNS name to businessnetworkacademy.com, and we say IP domain name bna.com. Now we'll go to the creation of the public and private keys for the SSH. We say crypto key generate RSA modulus, and the values are also minimum of 2048. Let's use 2048. The keys are generated. Let's enable the telnet and SSH on the VTY lines. We say line VTY 04. So when we say 04, we say we want to use all kind of lines. I mean, from 0 to 4, totally 5 lines. We say transport input, and the option is telnet and SSH. enter. Then we say login local. We haven't added any users here. Let's add a user. We exit from the line configuration and say username Bob. And the secret is 222. Let's be limited with just Bob username. No need to add Mary here. Let's save the configuration. Do right. Okay, now let's check if we are able to log into the switch tree from our PC. PC1. R3 load, but the IP address is ending with 10. And the protocol, let's say telnet. Let's try with telnet first. Say open. Username is Bob. Password is 222. As you can see, we are in the switch. Configuration, let's say show run. And we can see that we are inside switch, and we can even check that we have a username Bob with a secret hash of level 9, which is 256-bit hash. So it's very strong. And enable is also level 9, which is 256-bit hash, which is very strong one. We have set the VLAN IP address to this one so that we are able to connect to it, and we have a default gateway which we still didn't use. Let's try to use it directly from here. We say ping, let's say yahoo.com. Looks like it cannot ping the yahoo.com, something is missing, and the missing thing is the DNS configuration on the switch itself. Let's see if it can ping Google IP address 8.8.8.8. Yes, it can. So let's add directly from here the DNS configuration so that the switch can also ping domain names which are in the internet. Let's check if our router can ping domain names in the internet, yahoo.com. It can. Let's check our router configuration. Show run. Yes, the router is able to ping the internet domain names because it has received the configuration of the DNS via DHCP client. So in our case, we have to set the DNS server IP address manually inside our switch. Let's do it. IP name server, and then let's set the IP address and save it. Now let's check if we are able to ping any domain names from the connection which is available via the PuTTY of our Windows 11. Let's say do ping yahoo.com. And as you can see, now we are fully connected to the internet. Okay, next thing that we are going to do is we are going to connect via telnet and SSH from our switch and router instead of computer. So let's try. Exit from the configuration and say telnet to 192.168. 100.1, which is the IP address of our router, and we are on our switch. It is asking the name. We say, let's say Mary, and the password is 333. Enable, and the password is 111. And as you can see, we are inside our router. In order to go back to the switch, we just say exit. Let's try to SSH now. The SSH command is like this: SSH-L. Then we say the username, let's say Bob for this time. Then let's say IP address of 192.168.100.1. It's asking for the password. The password for the Bob was 222. And now we are back to router 3. Let's say enable. And the password is 111. Let's see if there are any statistics on R3. As you can see, it has some statistic here which says login success, Mary's source IP address is 110, local port 23, and the time. Oh, something happened. And then we have user Mary has exited TTY session. Then we have SSH connection from the same IP address, user Bob in this time, and the local port is 22. So as you can see, we are able to log in from the switch to the router and from the router to the switch. Let's try to log in from the router to the switch. Enable 111 and say, let's say telnet to switch IP address of 192.168.100.10. Username is Bob. We have only one user there. And the password is 222. Enable. And as you can see, we are inside our switch from our router console. Let's exit. Let's see if there are any logs on the switch. And the switch has also logs that there was a login success, user Bob, source address is 101, local port 23 and the time, and then Bob has exited TTY session. So we just demonstrated you that it is possible to connect to the router and switch not only from the boutique-like clients, but you are able to do it also via switch or router consoles. Let's see what other commands that are in the list and we haven't exported yet. Okay, this one is done. Login local done. Username secret password done. Crypto key done. Transport input done. IP domain done. Enable secret done. History size length. So if we go to the console, if we press on the up and down arrow keys, we can see some history commands there. Maybe not too many commands on the router. Let's try the switch. It could be that the switch has more commands. Let's exit from the router configuration. Now we're back to the switch. And let's go up, enable conf telnet. As you can see, there are at least 4 to 5 commands. Let's add some more. Let's say configure terminal, then exit. Now we have around 5 commands saved. History size, line configuration mode defines the number of commands held in the history buffer for later recall for users on those lines. So we are in the console line. We say configure terminal, line console 0, history, size, let's say 2. Now let's end it. And now let's try to go up and down, configure T and SSH L. As you can see that we can maximum see only 2 commands. What does it mean? It means that our CLI, the console line, is now able to save the history of only the last 2 commands, which may not be very flexible or useful. So it might be better to have a history of at least 100 commands. Let's change it back, configure terminal. You see, I even cannot reach to my previous commands and I have to dial them again. We say line, console 0, history, size, and let's say 100. The same you can do on the VTY lines, but I leave this one for your own practical exercise at your homes or labs. Next, what we can do is to explore the command named show running config begin VTY line. So this pipe actually brings us to the line VTY text in the router configuration. Let's check. Let's exit, and say show run pipe begin VTY line. As you can see, we see nothing. Why? Because I wrote that command a little bit different. It should be begin a line VTY. And as you can see now, let's clean this rubbish. And as you can see now, we see the portion which starts from VTY line 04, login local, transport input, telnet SSH. Let's choose something else. Let's say IP address. And as you can see, it starts from IP address now of this one and goes down. If you have a big running configuration and you want to find a specific command, you can use the pipe command with begin word to find the exact place that you are searching for in your configuration. Show crypto key mypub key. List the public and shared key created for use with SSH using the crypto key generate RSA global configuration command. Let's check. Show crypto key my public key RSA. And as you can see, the system shows us our public key, which is 2048 bits, has the name of switch3bna.com. Key is not exportable. This is the key itself. It has a key pair. Temporary key, usage encryption key. Key is not exportable. Okay. Next command is show IP SSH. List status information for SSH server, including SSH version. Let's check. Show IP SSH. We can see that the SSH is enabled and the version is 2.0. Authentication method, public key, keyboard, interactive password. The algorithms which are used for the encryption and hashing. And the RSA key itself, the public one. You can look into the details of this output at your home labs. So let's go to the next command. Show SSH. List status for the current SSH connection into and out of your local switch or router. So instead of show IP, we say show SSH. No SSH version to server connections running because nothing is connected. Let's have a connection. Let's simulate a connection. PuTTY, come back. R3 load and IP address is 10. And let's say open. Accept. Login as Bob. Password is 222. And let's see if something has changed. Show SSH, and we can see now that we have in and out with encryption of AES-256 CTR and hashing of the packets. OpenSSH session started with the username Bob in two directions. So it's input and output. So one is coming from the PuTTY to the switch and another one from the switch to the PuTTY. Okay, let's go for the next command. Terminal history size we already checked. Show history. Okay, let's see the history. Show history. As you can see, the system lists all the commands that we have used so far, which is quite useful. The next command that we are going to explore is command debug. Debug IP ICMP. Show me every ICMP packet you handle. For example, if we just say ping 8.8.8.8, you see these 5 exclamation marks that the rate is 100%, round trip time average, minimum maximum, and that's all. Let's say that we want to see more details about the ICMP activity on our switch. We say debug IP, and there are debug IP, and there are many options, but we want to use just one, which is related to ICMP. And it says us that ICMP packet debugging is on. Let's again ping some google.com. And as you can see now, for every packet sent, there is a specific message with the details, time, echo reply, source A.A.A.8, which is the Google. Destination is our IP address of the switch, topology-based DSP record. So we are having more details for the ICMP packets. The same is applicable for any other packets, but we have to enable it specifically, which we are not going to do in our lab. So in order to stop debugging of the ICMP or any others, we should say undebug all. And it gives us notification that all possible debugging has been turned off. No undebug all or undebug all are two commands which can be used for disabling the debug activity. The problem which you may arise with the debug that if you choose, let's say, to debug some TCP or UDP traffic, and if there is a lot of traffic going through your switch, your CPU on the switch may be overloaded and your console may hang. So be careful with that. Okay, the last thing which I wanted to show you is the number of the VTY lines which is supported by the system. Okay, if we say show VTY 04, we should see that we have 5 lines from 0 to 4, totally 5 lines, and none of them is being used now. Let's try to connect to it via our PuTTY. Let's say router 3, load. Let's say open. User Bob. Password 222. Let's see if there are any differences. No difference. Let's open one more connection. Right click and say new session. R3. Load. Open. Let it be Mary. 333. Enable. 111. Let's see if there is any progress. As you can see, we have stars here. So VTY line 2 and 3 are busy. But I don't like the detail that we see here. Let's see what else we can see. Let's say summary. Four lines never used, 3 total lines in use, 1 not authenticated lowercase. Okay, let's try show line instead. As you can see, the show line shows us which lines are busy. So busy lines are 2 VTY lines and the console line, the aux line is free, and we have 3 more lines which are free. We can also say show users. And we can see which users are connected via which port. So we have a console port without any user. We have a VTY0 with a Bob and VTY1 with a Mary. Let's increase the number of connections. We can also see here from which IP address they are being connected, as you can see. Let's try to connect via another computer putty. Let's say switch 3, load. But this is not switch 3, this is router 1. Let's say open. We say accept, and we say login as, let's say Bob, and password is 222. Access denied. I think we did something wrong. 222. Yes, I think the username was entered with some space. Let's cancel it. Start again. Switch 3 load. 1. User Bob. 222. And we are logged to the R3. Let's see the R3 statistics again. We can see there is user Bob logged from IP address of 100.100. Let's try one more connection. For example, from here, let's say new session, R3, load, open, login as, let's say, Mary again, and the password is 333. Let's open one more session, R3, load, open, login as, let's say, Bob, and the password is 222. One more session, R3, load, open, and as you can see, network connection refused. Let's see what is going on in R3. Show users. You can see that users have filled all the VTY lines and there are no more free logical connections to connect and manage the router. That's why we are being refuse it. Another command we can use show line. It shows all stars here that all the VCY lines are busy. Show line summary. One lines never used, 6 total lines in use, 6 character mode users. So as you can see from the latest test, we are not able to connect more than 5 concurrent telnet or SSH sessions to a router or a switch on a Cisco router. This is all what I wanted to show you in this lesson. If you have any questions, you can ask them in the comments section of the video. See you in upcoming lesson. I highly recommend subscribing to my YouTube channel so that you don't miss any new lessons or setup guides that I release.